Well, good morning. We are here today for Unit 2, Day 5, Atomic Mass, and we'll be doing some calculations here which will help you with your practice problems that you need to do tonight on the back of the worksheet. So let's get started. The atomic mass is the weighted average mass of the atoms in a naturally occurring sample of the elements. Now remember, when you look at the periodic table has the atomic mass units, and they are in decimals. And I've explained before that those decimals are created due to the fact that it's not a straight average when calculating how much of those elements are out there. Each element has its own sets of isotopes, and each isotope has a different amount of neutrons in it, which causes it to be heavier or lighter than the other elements' isotopes. The key here is that when you find these isotopes out there in nature, they're not all the same amount. So you have some that are small parts, a small percentage of the entire known isotopes, and you have others that are quite large. So that is something that we have to take into consideration. So remember that a weighted average reflects both the mass of the isotopes and the relative abundance of the isotopes, meaning how much there is of it. Okay? Relative abundance means that out of the whole pie, the whole 100%, it's not all just, if there's 3 isotopes, 33%, 33%, 33%. Some have less than that, some have more, and that's what you have to keep in mind, and that's why we get the decimals. Okay? One of the things that you need to be able to do to show mastery of this concept is to calculate the atomic mass of the element. And to do that, it's quite simple. You must multiply the mass of each isotope by its natural abundance. That is expressed as a decimal, and then you add up those products. Okay? Let's take a look at this conceptual problem just to give you an idea of how it's going to work. There's no math in this conceptual problem. There's just some estimating. All right? Our atomic mass of copper is 63.546 AMUs. Which of copper's 2 isotopes is the most abundant? Copper 63 or copper 65? Now remember, right here, the 63 and the 65 are telling you that it's an isotope. That is the mass number. Okay? So let's take a look at our goalposts. We have 63 and we have 65. The average, the weighted average is going to be somewhere between 63 and 65. If I'm estimating now where this is at, where it's going to fall, take a look at the timeline right here. Okay? Take a look at where it is when we list it out. We have 63 and 65. If the atomic mass is 63.546, that is closer to 63 than it is 65. What does that tell us? Yeah, that's right. That tells us that there must be way more 63 than there is 65. And that's why our atomic mass average is 63.546. This is an estimate, okay? But how about if we want to do the actual math? Well, here we go. This is on page 117, and here's the question. Element X, fictional element, has 2 natural isotopes. The isotope with a mass of 10.012 AMU, X10, has a relative abundance of 19.91%. The isotope with a mass of 11.009 AMU, X11, has a relative abundance of 80.09%. Calculate the atomic mass of this element. Okay? So thinking back to what we just did here a few minutes ago, talked about a few minutes ago, you need to take the average, the mass of isotope number 1, in this case X10, and multiply it by its abundance. You have to take the isotope number 2, or in this case X11, and multiply it by its abundance. Alright? Now 80.09 and 19.91 is going to give you all of the known isotopes of element X. So let's calculate the mass average. And here you can see that that's what we have done. 10.012 multiplied by 19.91. Now the first thing you need to do is remember you're multiplying by a percentage. So you have to move the decimal place 2 places to the left and then multiply. And when you do that, you get 1.9933. That's for X10. X11, its mass was 11.009, multiplied by its abundance of 80.09%. Move the decimal place 2 places to the left, multiply it out, and you get 8.8171. And then the next step is to add the two products, and then you get 10.810 AMU. That is the atomic mass unit. Now let's think about this logically. Does it make sense? We have 80% of it that weighs about 11. We have 20% approximately that weighs about 10. Doesn't it make sense that my average is going to be closer to 11 because there's more of it than 10? Yeah. And that's one thing that you have to do as well, is you have to think logically to make sure that your answer is correct. If you get an answer outside of 10 or more than 11, so less than 10 and more than 11, there's no way that you did it right. So you have to use a little bit of logic here too. All right? So following this same math pattern, I need you to do problems 23 and 24 on the back. All right? Thanks. Talk to you Monday.